Hello. So we're going to start with the basics of volume today, section 10.2. We're going to do that for prisms and cylinders. So volume is the amount of space contained in a solid. So all of these pictures here are solids or three-dimensional figures. Volume is measured in cubic units. So now you're going to start using inches cubed, feet cubed, meters cubed for your answers. The volume of an object is the number of unit cubes that completely fill the space within the object. So an easy visual would be this guy right here. So what you can imagine is on the bottom here, this right here is one cubic inch, if these are in inches. So that'd be 1 cubic inch. So you can imagine there are 8 of those, 4 on the front and then 4 in the back layer here. So in the first layer, you have 8 cubic inches. Also notice that the area of that base is also 8 inches squared. But the cubic is because of the 1 inch height. Okay, so now you can put another layer on there, and now you have a total of 16 cubic inches. So you're always going to want to do the base area. That's the first layer of cubic inches, and then times the height will tell you how many layers you're going to do. Okay, so for the formula, this is just capital B stands for base area times, and again, that has to be a perpendicular height. Okay, so base area times height, that's going to give you the 3 dimensions, and obviously that'll be the cubic units. So trying a couple of these. So I'm actually, so number one, what you have to be very careful about is you want to pick the base so that is what's being layered. So here, what you'll notice is it's sitting on this rectangular face, but you're not doing layers of rectangles to make this shape. Okay, you would actually do layers of triangles. So you can imagine that there was a bunch of triangle layers to make this prism. So in this case, the triangle is the base. So you got to be very careful because the base is not always what it's sitting on. Okay, so this is the triangle is the base. So just do the volume. Again, you're going to do the base area. So for a triangle, it's 1/2 base times height. Lowercase b is a two-dimensional side or a base, and then times the height of the actual prism. So you do have to be careful not to get your h's mixed up. So maybe you have h1 and h2. But in this case, you have a 5 here, a 13 here, so that means this remaining side is 12. You got to know your triples. That right angle will give us the base and the height. So the area of the triangle base is 1/2 5 times 12. And then you multiply that by the height or the number of layers you need to make the prism. So in this case, that would be 16. You need 16 layers of triangles to make that prism. Okay, you do put all of that together. So 1/2, I'm going to do 1/2 times 12 is 6, times 5 is 30. So then 30 times 16, I believe, is what, 480? And again, that would be inches cubed. Okay, number 2. So here, obviously, we have a hexagon, and then you would do layers of hexagons to make this prism. So the hexagon is the base. That is what you're finding the area of. So what I would highly recommend is that you redraw the base when it's not super obvious what the area is. So I'm going to redraw the hexagon. I know that one side length is 6, so I'll label that 6. And you're going to use your special right triangles to figure out this area. So I'm going to draw in my apothem, and then this is my 30, 60, 90 triangle. This will be 3, so the apothem will be 3√3. Okay, given that information, why don't you pause and find the volume of this prism. So welcome back. So you should have the area of the hexagon, so 1/2 apothem times the perimeter, so 6 times 6, which is 36. And then you multiply by the height of the prism, or the number of layers of hexagons. So I need 15 layers of hexagons to make that shape. Okay, so you're going to throw this into a calculator because I'm not sure what all of that is. So let's see. 1/2 of 36 is 18, but then I multiply by 3 and then by 15. So you should end up with 810 root 3, and that is in centimeters cubed. Okay, again, base area times how many layers you need, or the height of the prism. Okay, next one. So area of or volume of a cylinder, very similar, right? It's the exact same thing, really. It's just that for a cylinder, you know the base area is pi r squared because it's a circle. So this is the same thing as having that capital B. You really could have the same exact formula. Okay, so base area and then times height. Again, the height just stands for the number of layers, or the number, layers of circles that you need for the cylinder. Okay, be careful about units. You notice this is in foot and that's in inches, so I'm going to change this to 12 inches to start with. So be sure to look very carefully at units. But the volume here again is just that easy. So you do pi r squared and then times how many layers of circles. We have 12 layers of that circle. Okay, so I'm going to do 36 times the 12 in the calculator. So 36 times 12. And I get 432 pi, and then that would be in inches cubed. Okay, last one. So oblique. An oblique solid, as you can probably tell in this picture, is one that's sort of tilted to the side. So this is called a right cylinder, and then this would be an oblique cylinder. So this one's straight up and down, and this one's tilted. The important piece about oblique cylinders, and oblique prisms too, is that you still have to use a perpendicular height. So I still have to figure out the perpendicular height to use as my layers. So always use a perpendicular height when you're doing volume, just like you did for area. Okay, so going through this, I'm going to do volume. I'm going to obviously do the base area, which is the circle. And then you're going to multiply that by your perpendicular height. Okay, in this case, what you'll notice here, I have an 18. So let me write 18 over here as well. And I have a 60-degree angle, which is the tilt of the cylinder. Well, that creates a 30, 60, 90 triangle. So then I can figure out the height because I know this is 9, and then the height here would be 9 root 3. Okay, so I do the base area times the perpendicular height is 9 root 3. And so I'm going to do 25 times 9. So what is that, 225? And then pi, and then root 3. And this is in inches cubed. Now there is a really nice explanation for why you do the perpendicular height even on the tilted or oblique solids. So you can look that up in your book. I actually can't remember exactly what page that's on. Let me just double check. In here, sorry, you're just going to listen to me flip through pages here for a second. But in 10.2, yeah, so on page 532, it goes through a little bit of an explanation of that. So you can look through an explanation of this on page 532 if you are interested. Otherwise, just realize you're always using that perpendicular height. Okay, so there's the basics for volume. Again, chapter 10 starts out pretty easy, and I will see you next time.